lecture number 12 of our beloved course, Language and IT, Language and Information Technology. We finished so far talking about CAL or CORE, whatever you like to call it, and then we talked about corpus linguistics. Today we are moving towards the third main topic. You remember that I told you before that we have three pillars, three main topics in this course: CAL, corpus linguistics, NLP or artificial intelligence. So today we are moving towards NLP, natural language processing, and we would like to know what benefit we can get from natural language processing in our life. So let's get going with NLP, natural language processing. Natural language processing, NLP, is mainly how we can process language naturally through technology, through artificial intelligence, through computers. So it is computers use. We analyze, the computer analyze, understand, and then generate something for us. So we give the computer some input data. It analyzes this data, understands it, and then generate something for us. It's like the example that I gave you before, a robot. A robot analyzes the information, tries to understand something from you, and then generate something for you. It's like also nowadays mobile phone. Nowadays we speak to mobile phones through voice recognition applications or voice recognition features in some mobile phones. You speak to the mobile, it analyzes the input from you, understands it, and then generates information for you. So this is the basic idea of NLP: computer use, analyze, understand, generate natural language. So the computer generates for us natural language. It analyzes natural language, understands natural language, and then generates natural language. What's the difference between natural language and artificial language? Artificial language is predefined sentences that the computer can give you. It's like you have a computer with only predefined, let's say, 50 or 100 sentences. The computer can only answer from these sentences. This is artificial language. Why? Because the computer cannot generate something new. But in our case today, we are talking about natural language that the computer can gives us, that can give us natural language, not artificial language. So artificial language is something that we customize for the computer, and the computer only selects from these sentences to answer for us. But in NLP, no, it's different. The computer should give us natural language. From the analysis, from the understanding, it generates natural language. A somewhat applied field. Yes, it's not theoretical field. Somewhat, it's more applied field. Theoretical fields, it only philosophize, it only theorize, but there is no application. In NLP, we consider NLP to be more applied field. It involves theories, like we are going to say in this lecture and the next, but it has some application. Related to NLP, as we mentioned before, computational linguistics, CL. Well, this is very important. One important theme and one important component in NLP is computational linguistics. From computational linguistics, we can feed into NLP, like we are going to see in the next lecture we will see what do you mean by computational linguistics and how we have a parsing tree. From the parsing tree, you remember in the syntax course, you studied the tree diagrams, NP, VB, blah, blah, blah. All of these can be fed into NLP and computational linguistics. NLP takes all of these tree diagrams, so computers or machine are able to analyze and understand to generate natural language for us. So computational aspects of the human language faculty, more theoretical. So in computational linguistics, we take some aspects from the human language and we try to have some theories about these aspects to be set into patterns and sentences for our computers and our machines. So we simply we take sentences from humans, we study these sentences, and from these sentences we can have rules and patterns for the computers. We tell the computer, well, human speak like this, blah, 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 blah. This is what the computer wants from us. The computer wants from us, we tell the computers how human speaks. And how do we do that? Through studying human language. We study human language, we tell the computers human speaks like this. They start with NP, nano phrase. They start with, for example, I, or they start with a name, and then we have a verb, and all of these in a very complicated, sophisticated way. All of this is called computational linguistics. So we have a certain language for computers. They read these languages. It's like formulas, like we are going to see in a minute. So the computer can analyze and understand all of these formulas. Human language, interesting and challenging. NLP offers insights into language. So why do we study NLP? Because interesting, at least for me and some. If you don't find it interesting, well, that's something related to your interest, and we cannot convince you more than that. NLP is interesting, and also human language is interesting. I can give you an example of what people talk about in social networking. They start to analyze human language in Arabic. They say, well, for example, one of the wonders of the Arabic language that we say blah, 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 blah. And one of the wonders of, for example, Najdi dialects or Hassawi dialects or Hijazi dialects is they say blah, 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 blah. This is studying human language. We study human language in our daily life. Sometimes we criticize. Sometimes we make fun of other people's speech or dialects. This is studying human language, but sometimes for a negative purpose, not for a positive purpose. A negative purpose is just to make fun, but a positive purpose in our research is to make useful insights and useful information. So human language is interesting and challenging. Sometimes it's very difficult to analyze a structure or a sentence. NLP offers insights into language. Yes, from NLP, if we want to study NLP or design a project or a machine, NLP would give us more insights about language, because we need to build up a sophisticated system through human language. We will know more about human language, and we will know more about the interaction between computers and how they speak. And we will see how difficult sometimes to do this. Language is the medium of the web. Yes, nowadays we are in the world of, on the wide world web, in the internet, and we want to know how to communicate with other people, how to make things more advanced. So language is the medium of the web. Interdisciplinary linguistics with CS, computer science, psychology, and math. And this is very important. They all interact. Linguistics, the study of language, we need linguistics. We need computer science because we want to write special codes and special languages. Psychology, very important. We study the psychology of humans, so we transfer the same psychology to the machine or to the computer or to the robot or to the mobile phone, and also math. This is very important to design formulas to your computers to understand. So you need all of these. So a mathematician cannot do this alone. He should know some about linguistics and computer science and psychology. And a psychologist also cannot do this alone. He should have some knowledge about linguistics and computer science and math, and the same for the other. Help in communication with computers and with other humans. Yes, very important that sometimes computers communicate with each other, or sometimes interacting with humans, like machine translation. In a machine translation, you have this machine translator, like Google Translator, for example. You give the machine a sentence or a passage or paragraph, and you wait for the translator, or you wait for the machine to give you and generate a translation for you. So how can we do this? A machine translator should know all what have been said so far, analyzes, understands, and then be able to generate the answer for you. Ambitious yet practical. Yes, NLP is too ambitious, and we think we are moving towards improving more and more sophisticated applications. We started with a one-word machine translator. Previously, you have this machine just to translate one word, and then we moved into 2 words and a phrase, a sentence. Nowadays, we can translate a book through machine translation. So it's too ambitious, and we are moving to more advancements and more improvements. Someone would say, especially for machine translation, they are not accurate. Yes, they are not accurate, but compare them to the past, they are improving. And we are trying to improve the accuracy of these machine translations or machine translators. What are the goals of NLP? We have 2 goals: scientific goal and engineering goal. A scientific goal is to identify the computational machinery needed for an agent to exhibit various forms of linguistic behavior. So to identify the computational machinery needed for an agent to exhibit various forms of linguistics behavior, that means we need to specify and identify what is needed for the machine. Information, computational information, and all what have been said before, language, computer science, math, psychology. So the agent here means the computer, the machine, the mobile phone, whatever program needed for NLP. So this is the scientific goal. We want to know what is needed for that machine to behave or to give us or to generate for us linguistic behavior. We are calling them linguistic behavior because we don't want only just language. We want some behavior from the machine. If it is a robot, we are expecting some movement, hands movement, maybe head movements, maybe some gestures. For a mobile phone, we are expecting, for example, some linguistics behavior like getting surprised, giving incentives, giving different intonations. So this is what is called linguistics behavior. How can we reach this? This is the scientific goal. We do research, so we identify what is needed for that machine to give us linguistic behavior. Engineering goal: design, implement, and test systems that process natural languages for practical applications. This is the practical side. This is the application side. The engineers that design these machines and software, they want to test their systems, implement them, and then see how they are working, evaluating them to improve their qualities and their features. So we have two goals. Some scientific researchers do the research. Engineers take from the scientific researchers, they design and implement. It's like, for example, cooking something. You get the recipe from the scientific researchers. The chef starts to design the meal according to the recipe. Applications. What are the applications of NLP? Speech processing. You get flight information or book a hotel over the phone. So sometimes we phone up a company to get the flight status, or to book a flight, or to book a hotel. Sometimes some companies, they have these voice agents. They ask you some questions and you answer them. You just phone the company just to get some information, or just to book a hotel. They answer your call. To get this, press number 1. To get that, press number 2. So this is an example of speech processing. How do we design these? Through NLP and computational linguistics, or artificial intelligence. Information extraction: discover names of people and events they participate in from a document. You can sometimes extract information. Well, you ask, for example, a Word document, get us the word blah 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 blah, and it can give you the answer. Machine translation: this is an obvious example. You translate a document from one human language into another. Question answering: this is the example that I had in mind before. You phone up a company, they start to ask you some questions, and they interact with you. For example, what do you want to do? You say, I want to book a hotel. Well, to book a hotel, give me your name after the tone. You speak your name, and they say, your name is blah blah blah. Please give me your ID, your national ID, and you give them the national ID, and etc. So find answers to natural language questions in a text collection or database. Also, this is another example. They can sometimes, the machine can answer your questions from a text. You ask the machine, and from the database they can get you the answer. It's like Siri in iPhone. It's like the other voice recognitions in the mobile phone. You ask, for example, Siri in iPhone, how is it like in Riyadh? So it searches a database, the weather, the status of the city, and more information, and it can give you answers to your questions. So this is another example of question answering. Summarization: generate a short biography of Noam Chomsky from one or more news articles. So sometimes you can ask the machine to give you a summary. Well, give me a summary of Noam Chomsky from different sources. So they search all the database they have to generate a summary for you. So different applications for NLP, and they are all very useful. The general themes in NLP are the following: ambiguity of language, language as a formal system, rule-based versus statistical methods, the need for efficiency. So we are going to study them, some of them today, and the others in the next lecture, inshallah. So what do you mean by ambiguity of language? We have sometimes phonetic ambiguities, like right. We give the code right here to the machine, but it can read it as right. Okay. Sorry. Or maybe right, or maybe right, or right. So we have three pronunciations of the same code, and this is a problem to the machine. We have nowadays these online dictionaries, or the mobile versions of some dictionaries. They have the feature that you speak up the word to look it up for you. So if you say the word right, it can give you right, the word writing, or the word right, or right, the opposite of, or making some problems. We have also lexical ambiguity. Can. The word can, we know it is a model. I can play, I can speak, I can do this, but also it can be a noun. A can of Pepsi. You know Pepsi? It comes in cans. This is called a can. It's not a bottle. No, it is a can. A can of fish. A can of whatever. So we have also a lexical ambiguity. Computers sometimes do not know the difference between can, unless, as we are going to see, unless we provide more information to the machine. Structural ambiguity. I saw the man with the telescope. What is the ambiguity here? Either it means you saw a man holding a telescope, you saw the man with the telescope, or you saw a man using a telescope. You used a telescope to saw the man. Or it is the opposite. You just saw a man holding or carrying a telescope. So a structural ambiguity. Semantic, yes, the word dish can mean the physical plate or a menu item. Well, we have today's special dish. Does not mean a physical plate. No, just a menu item. All of these make NLP difficult. And that's true, yes. All these problems are obstacles toward NLP. How did you find these? Through research. A lot of people did many research, scientific research. That's the scientific goal that we talked about. They did some research and they found these problems. And they did more research to overcome these problems. So we can treat parts of language formally. Language, a set of acceptable strings. Define a model to recognize, generate language. Works for different levels of language. Phonology, morphology. Can use finite state automata, context-free grammars, etc. to represent language. So we should deal with language as a formal system. We give the computers a formal system. They generate information for us through these systems. I don't want to go into more details about this, just not to confuse you. Rule-based and statistical methods. We have some theoretical linguistics captures abstract properties of language. So we study human language and we say, well, we have different rules, like the rules we studied in grammar. Well, we have blah, blah, blah. So one way to design NLP is through this rule-based. We give the NLP, the rules, and then from the rules, they understand the rules and generate information for us. NLP can more or less follow theoretical insights. Rule-based model system with linguistics rule, this is what I talked about, that we model, we give a model to the computer or to the machine through the linguistics rules. We tell the computers, well, these are the language rules, analyze them, understand them, so you can speak like human. Or through statistical model system with probabilities of what normally happens. We will say to the computer, well, these are sentences from human language, and these are the most frequent sentences, rules, patterns, all the information you need, and probably you will have these models more than the others through some kind of frequency and statistics. So we have these two models. Hybrid models combine the two. Another model is to combine the two, rule-based and statistical methods, so we generate more efficient machines. The need for efficiency, yes, we need more efficient results. We don't want just to generate, for example, a machine translator and it gives us rubbish. We want more efficient work, and this can be through simply writing down linguistic insights. Isn't sufficient to have a working system, yes. So we cannot just tell the computer linguistics insights to give us sufficient feedback. Programs need to run in real time, be efficient, yes. And should programs be used in real life situations so they can be efficient and working for the purpose. There are thousands of grammar rules which might be applied to a sentence. Yes, this is another problem. We have thousands of rules that can be applied to just one sentence. Use insights from computer science to find the best parse. Use chart parsing, a form of dynamic programming. Yes, we need also insights from computer science. We need computer science people to join us in this. It's not only part of language. This is why we call the course Language and IT. So we need people from IT and people from language to combine both insights from language and insights from computer science. Computer science sometimes would say, well, this should be done this way. Linguists would say, no, you cannot do this because language, blah, 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 blah. So these are insights from language. And sometimes it's the opposite. Linguistics people say, well, this should be done in this way. Computer science would say, no, you cannot do this because blah, blah, blah. We have some technical problems, technical difficulties. So we need insights from both linguistics insights and computer science insights. So to use some tree diagrams and etc. I hope today's lecture was light and you absorbed what have been said so far. I think it's very, very interesting to study about NLP. Nowadays we have some paid courses for NLP. We offer this in our course in a very condensed way, and I think you will benefit, inshallah, from today's and the next lecture. Thank you for watching and attending, and all the best.